So a simple, straightforward solution to the problem of summing up two linked lists. Reality of things being the problem case is straightforward, and any nuances will be uncovered and explained in my solution. Now, this may be a lead code problem, but it's also a general problem of adding two linked lists with a function called add two numbers. So let's just do a TLDR. We are given the heads to two linked lists, L1 and L2, are pointers to the headers or head nodes of the two linked lists that we want to add together. So let me go ahead and create a comment. This would be a high-level overview of the problem. We create a new dummy node, create, a new dummy node to store the result of the linked list. Let's say sum linked list. Step 2, we would in some way initialize it to null pointer. So sum linked list. And we will keep a pointer to it. We also then would traverse both linked lists given by L1 and L2 simultaneously using the pointers started from their respective headers. Step 3. While traversing, we add the values of corresponding nodes in L1 and L2. Also, we must consider a carry, so along with any carry. So, not step 4, but what is a carry? If the sum of linked list node 1 and linked list node 2 is greater than 9, so anything from 10 to, let me check what's the highest number. So node value, the number of nodes, node value, okay, yep, so the highest value can be 9. So any value greater than 9 must be broken down into two single digits. Let's say we had 5 plus 5 be 10. We cannot store 10. We would have to store 0 and add 1 to our next sum. That is the carry. Step 4. If the sum is greater than 9, set the carry for the next addition. Step 5. We create a new node with the least significant digit of the sum and add it to the result linked list. So let me say sum linked list. Step 6. We move forward. Let me say we traverse our linked lists, that being list 1 and list 2, until both are null pointer. We know that null pointer means that the linked list has reached its end. In the end, we return a header to our sum linked list. So now note this, that the actual implementation of the add two numbers function will depend on one thing: the programmer who's programming it. This is my solution. So the first thing I do is create two list nodes, called list node first, list node second. I then initialize first to be equal to L1. So now first and L1 both point to the same memory address, being the first node in the respective linked list L1. Second is initialized to L2, where it also points to the first node in the linked list L2. I then create a vector for summed values. And the reason I did this is, initially I did not solve it this way. I solved it where I was creating the summed value, so a plus b, and adding them to a vector. Here's an example. Keep track of each summed value. And here's our carry, which I called remainder. So 5 plus 5 is 10, remainder would be 1. Now, if either is true, we continue. Read this way. While first is not equal to null pointer, or second is not equal to null pointer. Let's say second is equal to null pointer. So this will end up being true. This will end up being false. Because we're using OR, the logical OR, at least one will get set to true. So we can go into the looped content or the looped code. Create a variable called integer sum, not initialized to anything. And then we do a check. And first check is check if both pointers are not end of linked list. And we do this by just saying if first is not equal to null pointer and second is not equal to null pointer, if this ends up being true, sum is equal to the value of first. We'll grab the value pointed to by first plus the value pointed to by second, and we'll add remainder. If first is null pointer but second is null pointer, we'll do sum plus 0, accounting for first being at the end of the linked list, and we'll take the value pointed by second. We'll then add remainder. We'll do the same thing with second equal to null pointer. There's no need for an else if. Because at this point we already summed the value of remainder, we can set it back equal to 0. We then do a check. Check if sum is greater than 9 indicates that we have to set a carry. So while sum is greater than 9, we'll add a value of 1 to a remainder and we'll minus 10 from sum. We'll then take that summed value and push back or add it to our vector. Add value to vector. Now, if first is not equal to null pointer, first dot next. First, I forget what this is, the member access arrow operator. So first member access operator arrow next just means we go to the next node. This is just used to traverse the node. We do the same thing for second. If remainder is greater than 0. So once we're done with our loop, once we're done with this loop, and assuming we still have a remainder value, we will add that value to our summed values. We then create a list node called beginning, new node, and end. We set beginning equal to null pointer. We then traverse the vector containing each summed value. So for integer sum in summed values, we'll create a new node, dynamic memory allocation, and we will pass it the value of sum and null pointer. We're using the constructor defined in this one. We'll then say beginning is equal to null pointer, then beginning and end is the same value. Else end will be set to the next memory address, and end will become the new node. So that creates our linked list, then return a header to the new linked list. Let's go through an example. So we'll go through this one here, this one. So first time through, it's going to be 2 plus 5. So all of this is created. We'll check here. Is first equal to null pointer? No. Is second equal to null pointer? No. So sum will be first value, so it's 2 plus 5 plus 0, so 7. So will this end up being true? No. So it'll be summed value dot pushback 7. Next time through the loop, it'll be 4 and 6. This will initialize, and it'll be the value of 10. Sum is greater than 9. So it'll be remainder plus equals 1. Sum minus equals 10. 10 minus 10 is 0. We'll push back the value of 0. We'll then go back into our loop. It'll be 3 plus 4, which is 7, but the remainder 1. So it'll be 3 plus 4 plus here 1, be 8. Is 8 greater than 9? No. So we'll push back the value of 8. All of this will end up being running, and we return our node. And we'll be left with the value of 7, 7, 0, 8. And that's it.